All right, welcome back, everybody. Today we're going to be talking about 4.8b, which is what we call Ferris wheel problems. Now, yesterday we talked about how to take a graph and to write the equation from a graph. Today we're going to sit there and we're going to give you a word problem, and from that you're going to be able to create a graph, and then from that you're going to want to write the equation. So again, our objective is going to be stated right here. It says you will be able to write the equations for real-life application problems. So let's take a look here. So here's our first side. It says the graph below represents a Ferris wheel ride. What are the maximum and minimum heights for the riders? Now, one thing we should realize about this is that when a Ferris wheel is going around, regardless of where you start, your height is going to go down, and then it's going to come back up, and then it's going to come back. And you're going to repeat this motion over and over and over again. Now, this graph can actually represent the same thing. So in this situation, they started up top, they went down, they hit their lowest point, and then they come back up. And then they get to the highest point, and then again, they're going to head back down. And this would repeat for as long as they are on the ride. Now, looking at this graph, we can see that the highest point that the rider gets to is 18. And it appears that the lowest point they get to is 2. So the question is, how far is the Ferris wheel off of the ground? Well, in this situation, if the lowest point they get to is 2, then we know that the Ferris wheel, right, the actual wheel portion where people are riding must be 2 feet off of the ground. Now, the question then becomes, well, if that's the case, where is the center of the Ferris wheel? Now, an easy way to figure out the center is by taking the average of the maximum height and the minimum height. So if I take 18 plus 2 and I divide that by 2, 18 plus 2 is 20. 20 divided by 2 means that the midline, or the center of the Ferris wheel, is 10 feet off of the ground. Now let's dig into this a little bit more. So it says, the center of a Ferris wheel at an amusement park is 7 meters above the ground. So the center is 7 meters above the ground. So let's put 7 right there. And the diameter of that Ferris wheel is going to be 12 meters. Now think about diameter. Diameter is the distance across a circle. So if the center would be sitting right here, the diameter would be that distance above and below. Now we can break that down. If we know that it is 12 meters in diameter, that means there is going to be 6 meters above and 6 meters below. So when we come over here, 7 plus 6 would give us a maximum height of 13, and 7 minus 6 gives us a minimum height of 1. Let's move this up so it sits right in the middle, at least as close. We want to try to produce this as accurate as possible. Now it says the speed of the Ferris wheel is constant, and it takes 20 seconds to complete one cycle. So I'm going to put 20 seconds over here. Now, often in a lot of these problems, you can actually break this down because there's going to be points at which we can reference along the way. So half of 20 would be 10, half of 10 is 5, halfway between 10 and 20 is 15. So this one breaks down into 5s. I like to normally try to break it up into 4 different pieces like that. You'll see why in a second. Sketch the graph and write a function to model the height above the ground if the rider begins at the 3 o'clock position. So if our rider is beginning at the 3 o'clock position, that would indicate that they are starting right here. Actually, let's even just highlight this guy. He's at the 3 o'clock position. Now, let's just assume that our Ferris wheel is moving clockwise. My stylus just died. 1 second. All right, sorry about that. So as we come over here now, let's just sketch out what's actually happening. This is kind of why we already broke up our graph into those increments. So here's what we know. We know that the rider begins at the 3 o'clock position. So that's in the middle here. Now, if we assume that the Ferris wheel is moving clockwise, and I think for just any problem, we're always going to make that assumption that we are assuming clockwise, then what we know is that our rider would be going downwards before he would be going up. Now, what we do also know is so that if this Ferris wheel takes 20 seconds to get around, that he's going to be at the exact same height after 20 seconds here. Now, since we also know that this would be acting as a sine function. We know that at the middle of that increment, he would be at the same spot as he would have then moved from his initial starting position all the way over to here. We'd be at that same height, and then he would go up and come back. So coming over here, we can sketch a picture for this. So he's going to come down. He'll hit that minimum height here at 1 after 5 seconds. And then he's going to come back up. He's going to hit that midline right there. Then he's going to hit his maximum height of 13 at 15 seconds. And then he's going to come back to his original position. Now, this is a representation of a sine function. So coming over here, and the reason we know it's a sine function again is because of where we're starting over here. So we're going to come over here and we'll write out sine, right? Because we do know this is a sine function. Now, our amplitude in this problem appears to be 6 because we are going 6 above the midline and 6 below the midline there. So if we're going 6, then we want to have a 6 out front. Now, since our sine function goes negative to start or goes downwards to start, we're going to put the negative in front. Now, other things to consider, we got to get our period right in this situation, and that's normally the hardest one. But we do know that since we have a midline here at 7, that our ending value here will be plus 7. Now, this one is not going to have a phase shift since we are starting where we would expect a sine function to start. So in the parentheses, we're going to have x plus 0. In fact, all of the problems we're going to work on today are not going to have any phase shifts. We'll get into that more tomorrow. Let's focus on the period, though. Now, in this situation, our period is 20. That's how long it took for us to get back to our original starting position. So what we want to do is we want to take our 2 pi divided by our b value should give us 20. This is that same formula we were using yesterday. Now, taking advantage of some mathematical manipulation, if we take our 2 pi over 20, this would be equal to b. Right? We can basically switch these two pieces in order to solve this type of equation. And then we want to sit there and solve. So reducing down this fraction, this would be 1 pi over 10, and that would be our b value. So 1 pi over 10 is the value we want sitting right here. Now, this question did say, it says sketch and write the graph of a function to model the height above the ground. So in the bottom here, we do know that this is time, and we know that this is height. So we should really change up some of our variables over here to make this work. So we're going to say h of t, so that's the height with respect to time, that's really what this idea is saying, is equal to negative 6 sine of 1 pi over 10. All of that's correct, except for since t is our input variable right here, this should actually be a t instead. That tells us that t is really our x variable in the problem here, which makes this our answer. Let's take a look at another one of these. As you do a few more, they start to kind of click together a little bit better. So in this situation, it says that a Ferris wheel takes 8 minutes to complete a full cycle. So we're going to come over here. Here's going to be 8. Just like I did before, I'm going to divide this up. So I'm going to make this into 4 because that was half of 8. Half of 4 is 2. Between 4 and 8 would be 6. What we do know here is that our Ferris wheel has a diameter of 20 meters. 20 meters is this distance right here. That means 10 above the center and 10 below the center. It says if the Ferris wheel is 2 meters above the ground. So 2 meters above the ground would be the lowest on this. And then we do know that we have this 20 meter diameter. So we're going to go up 20 meters from that 2 off the ground. So we'd be at 22. Notice that's not 20 because we're already starting 2 meters off the ground. We should find the midline here because that's going to be an important part in this problem. So to find the midline, take your high point, add that to your low point, and divide by 2. We're essentially taking the average. 22 plus 2 is 12. 22 plus 2 is 24. I'm jumping ahead of myself. 24 divided by 2 is 12. So 12 then becomes my midline. Now coming over here, it says if the ride begins at the 6 o'clock position. So that means we are starting all the way down here at the bottom. Again, we're assuming that we move clockwise in this situation. So we're going to begin moving upwards. So we're starting down at the very bottom. We're going to begin moving upwards. Then we're going to hit our maximum height. That's going to be halfway in between our 8-minute cycle. Then we're going to start the descent. And finally, after 8 minutes, we'll arrive exactly back where we started. So this would be our sine function right here. Or sine, or I should say sine or cosine function. Just like so. So to sit there and write the equation for this one's going to be a cosine function because of the fact we are not starting our graph in the middle. So we're going to have cosine. It looks like our amplitude here was 10, 10 and 10. So we're going to come over here, we're going to say 10. And then since we're sitting at the bottom, we're going to make that a negative 10 cosine. Now again, the period becomes the hardest part, but there is no phase shift in any of these problems today. So we're going to do this again as h of t. So we're going to say h of t is the height with respect to time. So we're going to have t plus 0 inside. That means no phase shift. Our midline in this situation was 12, so we're going to say plus 12 at the very end. And the last part we got to figure out is our b value. To figure out your b value, you just want to take 2 pi over b. That's going to be equal to our period, which is 8. We're going to sit there and switch these two pieces, so we'll get 2 pi over 8. That's going to be equal to our b value. Reduce this down. This will be 1 pi over 4 is what b is. So we're going to have 1 pi over 4 in that situation, and this would be our function, right, that models our height with respect to time. Let's take a look at another one. So coming over here to this next one, it says Sam is riding his bike home from school one day, and he picks up a nail in his tire. The nail hits the ground every 2 seconds, right, because it's going to be nail, and then it's going to be click, 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 click every time he comes around. So every 2 seconds, his wheel is making a revolution, which means it hits the ground. The maximum height of the nail would be 48 centimeters. We're just going to assume that the tire does not deflate. Sketch a diagram of the movement and write a sinusoidal equation that describes the situation. Remember, that means sine or cosine. So we're going to start our situation here with the nail hitting the ground. What we do know is that the nail hits the ground every 2 seconds. So after 2 seconds, the nail is going to hit the ground again. And then if we wanted to repeat that, it's going to hit the ground again after 4 seconds, right? That's maybe a little bit more than we really need here, but that's okay. Now, just like we did before, we want to take each of these periods and divide them up. So but halfway between 0 and 2 is 1. Halfway between 0 and 1 is 0.5 seconds. And then this would be 1.5 seconds, which is halfway between 1 and 2. We can do the same thing over here, although this would really be considered extra at this point because we don't need to graph this whole function, but maybe it will help for understanding. So in this situation, we're going to just assume that we're starting with the nail on the ground, and then as we know with the bike tire moving around, the nail's then going to go up. It's going to hit a maximum point, and then it's going to come down and hit the ground again. It's going to go up, and then it comes down again. So in this situation, we do know something about how high it went up. It went up 48 centimeters. And that's going to happen exactly halfway between when it hit the ground and when it hit the ground again. So that's going to happen here at 1, and it would also happen here at 3. Now we can already start to see what's happening here. The last piece we're really missing, though, is our midline. So our midline in this situation, if you just take your lowest, which is 0, add that to your highest, which is 48. Take the average of those two. 48 plus 0 is 48. 48 divided by 2 is 24. That is the distance of our midline. So that's going to tell us where we are coming through and at exactly what times. So at this point, you could sketch your function. Let's try to do that better. Just like so. Now, we're asked to write the equation of this. So again, let's do this in terms of the height of the nail in respect to time. So we're going to say h of t is equal to. So again, this would be a cosine function because we are starting down here not on the midline. So we're going to say cosine. Our amplitude here would be 24 because that's the distance between our midline and our max and our min. So we're going to say 24. And then we're going to put a negative in front of that because of the fact we are starting below the middle line. So we're going to say negative 24 cosine. We're going to leave our period. Again, we're not dealing with phase shifts today, so we're going to say plus 0 right there. And then since our midline is at 24, we're going to say plus 24. Let's wrap this up now. Let's get that middle b value. So 2 pi over our period. Our period here is just 2 in this situation. So 2 pi over b is equal to 2. Switch these two. We get 2 pi over 2 is equal to b. Our 2's cancel out, so we find out our b value is just pi. So we're going to put our just pi right there. And this would be the equation that models that situation. Nice job. Let's keep going. Looks like we have, what, 2 more problems here. So here we go. It says a pendulum on a grandfather clock is swinging back and forth as it keeps time. A device measures the distance the pendulum is above the floor as it swings. So if you had a grandfather clock, here it is. There's the clock. There's normally this thing in the middle called the pendulum, and that pendulum is going to swing back and forth over and over, and that's what keeps time. Now, as we can see here, there would probably be a spot where maybe you're at the maximum height, right? This would be at the maximum height, and then as we swing, we would hit the minimum height, and then again, we'd hit the maximum, and then we'd swing backwards the other direction. We're going to repeat that over and over, and that's going to make a sinusoidal function again. It's going to be going up and down, up and down, up and down. So it says the device is measuring the distance the pendulum is above the floor as it swings. At the beginning of the measurement, the pendulum is at its highest point, which is 36 centimeters above the ground. So we're going to have 36 sitting right here. It says exactly 1 second lower, it's at its lowest point of 10 centimeters above the ground. Sketch the sinusoidal function and write an equation that describes the situation. Now, the first thing we need to realize is that we are not at a period yet. Since we've only gone from the highest point to the lowest point, we need to go back to the highest point in order to actually sit there and achieve a full period. Now, here's what we need to think. The minimum happens exactly halfway between the high point and the next high point. So what that means is that the next high point is going to occur exactly a second later, which is at 2. Now, of course, we can sketch those middle points if we want to give ourselves a little bit more detail. I recommend it. That's going to be where we're crossing our midlines right there. So now let's figure out our midline. To find your midline, we're going to take 36 plus 10, our max plus our min divided by 2. That's going to be 46 divided by 2. 46 divided by 2 is 23. So 23 is going to be our midline, which means we have an amplitude of 13 above and below that. So we can sketch in our midline right here. Again, we're going to be crossing that at those other middle values. And then we can sketch the height of that pendulum with respect to time. So we come through, come back up to hit, and then of course we repeat that over and over. So we can see here that we have a cosine function. Our amplitude is 13. We can keep that positive since we're starting above the center line. So we have cosine. We're going to leave our b value blank. We are working with the height with respect to time, so we're going to say h of t again. No phase shift here. Our midline was 23 centimeters, so we're just going to say 23. Now let's figure out our b value. So we're going to take 2 pi over our period length, which we found was 2. 2 pi over 2 means our b value is going to be just pi. And just like that, we're done. Here's another one. Last one. Jared's riding a Ferris wheel. The Ferris wheel has a diameter of 18 meters, and the center of the Ferris wheel is 6 meters above the ground. Okay, so Jared's Ferris wheel. So if it has a diameter of 18 meters and the center is 6 meters above the ground, so here's the center. Now, a diameter of 18 meters means we're going to be going 9 above that and 9 below that. So this Ferris wheel is actually going to be passing underground here a little bit, which is going to be kind of a unique Ferris wheel. 6 plus 9 would put us at 15. 6 take away 9 would put us at negative 3 feet below the ground. Again, the center is going to be indicative of your midline. It says it takes 40 seconds to complete 1 revolution, so let's just make this 40. We'll cut that in half and make that 20. This would be 30 then, and this would be 10. Sketch the graph of the movement and write the function. So it does say Jared is riding a Ferris wheel of 6. Sketch the graph of the sinusoidal function. So let's just assume, so since they don't actually tell us where Jared gets on, this would be a bad problem as far as I'm concerned, because without telling that, we don't really know where their graph starts. So let's just assume he starts underground in this one, is where they have their little loading station. So if he starts underground right here, we know that at 10 seconds, he would be crossing that midline. At 20 seconds, he would be at the highest point. At 30 seconds, he'd be back at the midline. And at 40 seconds, he'd be back underground. So coming on over, we can see our function would look something along the lines of this. This, of course, is a cosine graph, so we'd have cosine. We know that our amplitude here would be 9. That's always half of your diameter. Since we're starting underground, we're going to keep that at -9, or we're starting below the midline. Let's leave our b value blank. Again, we'll do this as height with respect to time, so this will be t plus 0 plus your midline of 6. To find your b value, you're going to take your 2 pi and divide that by your period, which is 40. 2 pi over 40 would make this into 1 pi over 20, and that will be our b value. So 1 pi over 20, and there we have it. That is the function that will model this. With that being said, that's all we got for you. Now it's time for you to go and practice. So your homework today is going to be worksheet 4.8a. Thank you guys so much for watching. I hope you have a great day. Thanks.